Welcome, welcome, welcome to lesson 5.4, finding slope on real life graphs. Miss Wall, when are we ever going to need this in real life? Well, here's when. At determining the slope and y-intercept from a real life graph. That's right, real life. Flip the page for me. So when we look at this, we need a little blast from the past. We need to think about slope mean, right? So as we recall, slope is the rate of change, right? That's another word for slope. It is our m in our equation y equals mx plus b. And also to find it on a graph, remember we do the change in y over the change in x. Remember that y over x that we did? So let's bring it all back in together, right? And on a graph, remember to find it, we could do rise over run. Okay, so it's the rate of change. It's how much we're changing in our y value over how much we're changing in our x. So next, the y-intercept. Well, what is that? Remember, when graphing it, the y-intercept is our initial value. It's our starting point, right? So in other words, that means when x is 0, when our input is 0, our y-intercept is what we get as our output. And also remember that it's b in our equation, okay? So remember, the equation of a line is y equals mx plus b. Miss Wall, make sure that x is in there. M is the slope. B is the y-intercept, okay? So it says, please find the slope and y-intercept of the graphs below and write the linear equation for each. So they gave us that it's linear, right? They're both lines, they're both functions, so let's write these equations. So if we start here at -4, and then we have this point up here, how far are we going vertically over horizontal? So our change in y over our change in x gives us our slope, remember. So m, we went up 1, 2, 3, 4, and we went over 1, 2. So our slope is 4 over 2. Well, Miss Wall, that's just 2, right? And then our y-intercept, our b, is where our line crosses our y-axis, which is right down here at. So our equation is y equals 2x minus 4, right? All right, so now let's look at the next one. Here we have two things. We need our slope and our y-intercept. So let's mark our 2 points that they have here. Now notice it's going down, it's decreasing, which means I'm going to have a negative slope. I kept falling off the tree, right? So it's going down. Well, how far down is it? 1, 2, 3. And how far to the right is it? It looks like it's 5 to the right. So our slope is -3/5. Okay, now our y-intercept b, where does this line cross the y-axis? Well, it crosses right here at 3. So our equation is y equals -3/5 x plus 3. All right, okay, flip the page for me. Some real world context here. So I'm going to zoom in. So here we're given a graph, but here it says that the y values are represented by pages and the x values represented by time. I wonder what that means. Well, it means that however many time I put in, I'm going to get the number of pages that are maybe read, right? So in this case, what is the slope of the graph? Well, this is a point right here, so let's mark it. This is a point. But be careful, our y-axis here, it looks like it goes up by 3 each time. Be very careful to the scale there. So here it looks like I have to go up 3 and then to the right 2. So the slope of my graph is 3 change in y over my change in x. So what does the slope mean in the context of this problem? Well, remember, slope y over x. So that means our y is 3 and our x is 2. Y stands for pages. X stands for minutes. So what does the slope mean? Well, it means that we read 3 pages per 2 minutes, right? Every 2 minutes, we read 3 pages because our x value is represented by minutes and our y value is represented by pages. Okay? So now looking at the next one, what is the y-intercept of the graph above? Well, our line crosses the y-axis at 0 is our y-intercept. What does that mean though? Well, that means that I read 0 pages in 0 minutes, right? So I read 0 pages in 0 minutes. Okay, let's take a look at the next one. We're having water in an aquarium is what it's titled. So it looks like we have days for our x values and depth for our y values. And if I look closely, it looks like here it goes from 0 something 4. So this must mean it's going up by 2's each time, right? And here it looks like on my y-axis it's doing the same thing. It's going in increments of 2. So that's important to keep in mind. Now remember, y over x is out to find our slope. So this means that it's going to be the depth over the days. So maybe it looks like the water is declining because the depth is getting smaller as time moves on. So maybe it's talking about how much water is being maybe drained from the aquarium or is being lost from the aquarium per day. Okay, so it's y over x. So let's figure out the slope of this. So for my 2 points, I'm going to mark this one and this one. These ones seem to be my best points. So I'm going to draw my triangle. Now I'm going down, so I know that my slope is going down, so it's going to be negative. Here it looks like I dropped 2 and then 2 more, which means I'm going to drop 4 total. Looks like I'm going 2, 4, 6. So my slope is negative 4/6. And it looks like that reduces to negative 2/3. So the slope in my problem is negative 2/3. So remember, this means that my depth is decreasing 2 inches every 3 days. So in the context of this problem, it means that the water decreases oh my gosh, it's not inches, Miss Wall. You're crazy. It's milliliters. Why would you measure water in inches? Hello. Every 3 days. Okay. So what is the y-intercept of this graph above? Well, it looks like it crosses the y-axis at 12. So 12 is my y-intercept. But what does that mean? Well, remember, y-intercept, that's your initial value. When we make a graph, that's where we start, right? So that means that after 0 days, so our starting point was 12 milliliters. So the water in the tank started at 12 milliliters. So you could also maybe write that initially we had 12 milliliters of water in the tank, right? That's the same thing as where it started. It's that initial value. Okay. All right, go ahead and flip the page for me. Let's take a look at this one. So it says, use the graph for questions 4 and 5. A plumber charges a set fee for each house call plus an hourly rate, as shown by the graph. It says, what is the slope of the lined graph above? So if we look at this, I need to mark my 2 points. I'm going to pick this one here and this one right here. Okay, so to find my slope, I know I need to do y over x. So how far is it going up and then over? So here it looks like it's going in increments of 25. So I'm going up 25 and 25 more, which is 50. And I'm going over 1. So what this means is I have $50 because y is represented by money. For how many hours? For 1 hour, right? So 50 is my value here. Looking at 5, it says, what does the slope represent? Well, if we look back to our slope here and what it means by our money being our y and our x being the number of hours, is that it costs $50 per hour. So does that mean it's the cost of materials for each plumbing job? Well, this has nothing to do about materials. This is talking about how much we charge. But I'm going to keep it just in case. The total charge for any plumbing job? Well, this isn't total. This is per hour, right? The set fee for any plumbing job, well, it looks like the number of hours increase, the plumbing job price goes up. So it's not a set fee. It's not constant. The hourly rate charged by the plumber, it's $50 per hour. That seems like an hourly rate to me. So I'm going to pick D as my answer. Okay. All right. Now I want you to flip the page. Let's take a look at this next one. It says a shipping company uses the following graph to show its customers the cost of sending a package based on the weight of the package being sent. All right, so it looks like the more weight the package is, the higher the cost is, right? Because it's an increasing graph. So what we need to do is determine the rate of change of the function. Well, what does rate of change mean? Well, that's slope, right? So we have to find the slope of the function, and we have to find the y-intercept. So it looks like here it's going up by 1 each time. It'll be a 2 here. And then over here, it looks like it's going to be 2 as well. So we have to figure out how much are we going up and over there for our slope. So I want you to take a moment, find the slope, say what does it mean in this scenario? Determine the y-intercept of the function and what it means as well, and finish this problem for me. If you have any questions at all, please don't hesitate to raise your hand and get it checked. Okay? All right, welcome back. Really quickly, your slope should have been 5/2. We went, is that true, Miss Wall? 1, 2, 3. No, Miss Wall, it's not true. It should have been 3/2. What are you doing? 3/2 because it went up 1, 2, 3 over 2. Right? So what does that mean? Well, the y is our cost. So that means 3 over 2 y over x. So that means it cost $3 for every, our x value is pounds, so for every 2 pounds. Determine the y-intercept. Well, this crosses the y-axis at 2, so my y-intercept is going to be 2. Explain what that means. So having this be 2, it costs $2 to send a package, Miss Wall. To send a package. The package has no weight. Okay? And then, of course, here it says, why doesn't it extend to the left side? Well, if it was way over here, that would mean that it has negative weight. Can a package have negative weight? No. Right? So it can't weigh or cost a negative amount. All right? All right, so flip the page for me. What I would like you to do now is look at the next 2 problems on your own. So you're going to do this problem here, talking about the water in the tank, and you're going to look at this next problem here, talking about jet 1 and jet 2. Please use your problem-solving skills on this. Think about it, okay? Don't try to act fast. If you have any questions, feel free to raise your hand and ask, but really think through the process of these and think, what is the graph telling me? What do I need to find from it? Okay? Please remember to raise your hand after you're done with those 2.